Hello, this is Caleb Arend, and this is the blog post for Class 8 for JavaScript 411 for the Austin Coding Academy Bootcamp. Uh, Today, I'm going to be going over a few questions here. The first is going to be just something in words, like discuss in words something you learned in class today or this week. And I'm actually going to share my screen here, and so we can see these. Discuss in words something you learned in class today or this week. How does hoisting work in JavaScript? Why is setState in React async instead of sync? And how is the virtual DOM more efficient than what it says here, dirty checking? And I'll be explaining what that is as well. And so let's dive into those. The first one, well, what is something that you learned today or in class or in this week? And so one thing I learned was higher order components and things like protected routes and things like the importing in React Redux and using Redux and then using, I think it was both their browser router. That's more like the actual, that's not React Redux, but it's another example of another higher order component. But for the Redux, using the state.js file, the reducers.js file, and then using a provider that's imported from React Redux and wrapping the entire app in React, and then using all of that to give global state to the different components so that each individual component can pull state from the Redux provider no matter where they are. So learned a little bit about higher order components. Next question is, how does hoisting work in JavaScript? So hoisting, if we look at MDN here, they define hoisting as referring to the process whereby the interpreter appears to move the declaration of function, variables, or classes to the top of their scope prior to execution of the code. What that looks like, I think they have an example down here, is that they define this function, cat name, that takes in a parameter of name, and then it prints out to the console, my cat's name is, and that variable that was passed in for the parameter, and then they're invoking the function before it's ever defined or declared. So that invocation is possible because of JavaScript function hoisting. Now, I'm more familiar with the function hoisting, and that's I think the more effective use of this. It's more a reliable use. You can declare a function and define it down here, and then you can call it up towards the top of the file, because when that file is run, that function gets hoisted to the top, pulled to the top, so that it is declared and defined at the very top of the file before the rest of the file begins to be read. Where it's, I believe, less reliable is when variables or classes are declared. I don't think that they can reliably be used in this way. MDN even has a note that says that doing so, using variables or classes, like calling them before defining them, can lead to unexpected errors and is not generally recommended. So that is JavaScript hoisting. Next question, why is setState in React async instead of sync? So if we go over here to the React docs and we look at their main concepts, number 5, state and lifecycle, and it's about 3/4 of the way down the page, it says that state updates may be asynchronous. React may batch multiple setState calls into a single update for performance. And so why is it async instead of sync? Well, because they wrote it that way, it looks like. And it says that like they want to group things together so that if the virtual DOM has to be re-rendered, they want to put as many changes as possible into one re-render instead of calling multiple re-renders of that virtual DOM. And it says because this.props and this.state may be updated asynchronously or at different times, you should not rely on their values for calculating the next state. So if we were looking at a counter and state has a counter in it, and it's calling this.setState and changing the number that's in that counter, like if you had a clicker on the page or a button that counts 1, 2, 3, 4, 5, 6, it changes this dot state dot counter plus this dot props dot increment, and it's saying that that's the wrong way to do this. It may fail to update the counter. But it says that if you would use then an anonymous function instead, and you pass in state and props into the parameters of that anonymous function inside the setState method, and then pass it the new counter key and value, you pass in the current state of the counter plus the props increment, then that should update the props and then update state. And so it has another example down here. This one is implicitly returning this using the arrow function and the parentheses. This one is using a function with the parentheses and the parameters and then the curly braces with a return statement and curly braces in there. So overall, big summary, bottom line is they grouped different state calls or state updates asynchronously so that it could decrease the performance cost on the rest of the app, it looks like, and not have to re-render the virtual DOM repeatedly. And then next question is, how is the virtual DOM more efficient than what they call dirty checking? And that, if we look here at this visualization from CodePen, the dirty checking, what they mean by that is when they refer to how an application could look at the DOM and see and check every single node. And so if there's a div that has header, main, and footer, and all these different elements underneath those, it recursively checks every single one of those. So div, header, h1, nav, anchor, and then div, back to div, main, image, and all these p tags, and that a tag, and the footer, and the ul, and the li's, and the a's inside there, and recursively checks every single one of those. Well, React doesn't do that. React goes through, and since it creates a virtual DOM, it holds the state of some of these different React elements, especially the ones that have different props that they're using. And since it uses that virtual DOM, it just keeps track of the changes. So if something changes here in the header and something changes in the footer in one of those LIs, then when it re-renders that virtual DOM, it only checks the changes and only tracks the changes in that header and the change in that LI. It doesn't check every single element. It only checks the changes. And then it updates those little pieces of the DOM instead of updating the entire DOM or checking the entire DOM again in every node within that tree. So those are the answers for these questions. This is the blog post for class 8. Thanks much for listening.